Hey, math friends, our learning target today is that I can review everything in the percents unit. You probably are going to want a calculator today since everything is out of 100 and we'll be doing a lot of conversions in our calculator. So if you want to pause video and go grab it, go ahead and do that. So this will be a pretty long video as it's everything that we're covering in the percent unit. It's a review, so I'm not going to do full instruction on every single target. Reach out if you need help on individual targets because we can always reset any of your videos. All right, so here we go. Amy's shooting percentage is 75%. By definition, that's 75 out of 100 is how many she would make mathematically speaking. That doesn't mean she shot exactly 100, but that's how many she would make if she shot 100. She made 15. How many did she shoot? So you have to figure out where to put the 15, where to put the X. So you have to figure out which one's bigger. Well, the bigger thing is the X, which is how many shots she took. She didn't make them all. She made 15. She shot X. So we're going to take cross products and solve. You also maybe notice a pattern here of is a relationship happening perhaps. So I can see that I can divide by 5 there, but I won't do that shortcut for now. So we multiply these out. We get 75x equals 1,500. Divide both sides by 75. Copy, paste, and we know that Amy shot 20 shots. So in order to get 75%, you have to, this would have to be a 20. So 15 out of 20 is 75%. So first answer is that she shot 20 shots. All right, same kind of setup, just a different entry point. Nathan attempted for 40 free throws. That's the total. He made 30. So he made 30 out of, there's my out of 40. What percent? So in this scenario, we're talking about that we have to find the percent out of 100. So if we take cross products in solving, then we would multiply these, which gives me 40 times x. We would multiply these, which gives us 3,000. We're going to divide both sides by 40, copy, paste, and we get x is equal to, so we have 3,000 divided by 40 is 75%. So still doing cross products, just figuring out where does the x go. Every scenario is a little bit different. Okay. Continuing on with percents. So what about test scores? They operate in the same capacity. We just need to know, if we're figuring out the percent, we need to get it out of 100. So in this first example, it's a beauty because it's a social studies test. The teacher made it out of 100. The score was 78 correct out of 100. No math needed there at all. It's just 78%. That it would be a C, maybe C plus, depending on the grading rubric. So that one is awesome because we don't have to do any calculation there. It's already out of 100. So now let's take a look at the ILA test score, so your English test score. In this test, the score was 34 out of 48. And if you want to figure out your percent, this has to turn to out of 100. And there's other ways to solve these, and I identified that in the video, but the learning target from the state of Minnesota in this particular lesson is to use a proportion to find the percent. So, if you're working with somebody else and like you could just divide and multiply by 100. That is true. You can. We're just following the learning target for today's work. So there are faster ways to solve. 48 times x. We multiply the other diagonal is 3,400. That's called cross products. Isolating the variable x, then we would divide both sides by 48. Copy, paste. We are looking for the percentage. So this is a 1 here. X equals 3,400 divided by 48 is what percent? I'm going to round it. It's 70.8%. But for simplicity's sake, I'm going to call that 71%. 71%. And 71% would be on the low end of the C this time, maybe more like a C minus. So that's figuring out grades with percentages using cross products. In this unit, we also talked about discount and tip and tax because they're all percent based. So in this page is going to cover some of those skills that we worked on in real life. You buy jeans that cost $42. That is the price before the sale. So that's the price on the sticker. And then you see the sign that says 40 or 25% off. So there's a discount. So $25 out of 100. If it were $100, you would get to take 25 off. But it's not 100, it's $42. So you have to figure out how much you get to take off first, and then you can figure out how much you pay. So let's take cross products and solve, figuring out the discount. So we multiply those, multiply those. So we get 100 times x equals, the other diagonal of 25 times 42 is 1,050. Now we're talking money here. We divide both sides by 100. Go ahead, pause the video if that's too fast, is $10.50. Now I put that placeholder in there because it's a money problem. That's how much you get to take off. That's what you get off on the sale. The 25% would be $10.50. Now I'm going to erase some things just so I have some space to write. So go ahead, pause if that's confusing, but I'm going to erase. So we have that the price on the sale was $42, or the price before the sale, and you get to take $10.50 off. So the question is asking here, what do you pay? How much do you pay? And so you would pay $31.50. You can definitely use a calculator for that. We call that the sale, because it's on sale, the sale price. That's the price you pay with the sale discount. So kind of two steps there. First, find the discount and then figure out what you pay. Next target is on tipping. You go out for dinner. The meal costs $73.28. You leave a 15% tip. So that means for every $100 you spend, you would tip 15. Now that doesn't mean every meal you ever buy is going to exactly cost $100. So that means we have to make a conversion. We have to keep it proportionate. So how much would you leave for a tip? If it was less than $100, it was $73.28. Now the actual question is asking how much total money do you need? So we have to pay for our food and we have to pay for the tip. Now tip is a choice technically, but in this problem, it says we are going to leave a 15% tip. Okay, so let's figure out how much are we going to leave for the tip, and then we'll add it on to the cost of the food. So we get 100 times x is equal to the $15 tip times the $73.28 is 1099.2. We're going to divide both sides by 100, copy, paste, copy, paste. So we get x is equal to $10.99 for tip. Now, of course, if you're really tipping in a restaurant, you most likely are going to round that to $11 instead of counting off, 99 cents. So the actual question, though, we got to make sure we answer the question, is how much money do you need? Well, here's our scenario. You have to pay for your food at $73.28. Sorry if you can hear my dog barking in the background. And then you have a tip of $10.50. So food plus tip means the final there is $83.78. That is how much money you need for food and tip in your service. So let's talk about this next target called percent of change. How much does something change? This is a scenario when you could have greater than 100%. Skyview currently has 813 students. So I'm going to put C for current. Next year, we will have 776. So clearly that's a decrease that's happening. So the first thing is to figure out how much is the decrease. So 813 minus 776. Okay, so we are going down 37 students. So we have a decrease of 37 students. I don't really need to have that arrow there. I've already identified that it's a decrease. So 37 is what we call in math the change. I like to use a triangle for that, meaning change. That's how the change that's happening. The key to this entire process of percent of change is you have to put the original value on the bottom, which means the first value in time. Over the course of time, what happened first? Well, this year happened first because next year hasn't happened yet. So the 813 goes on the bottom because that's the thing that happened first. And then we're just finding the percent of change. So we're going to take cross products and solve. We're going to multiply those out. So that gives us 813x equals 3700. We're going to divide both sides by 813, copy, paste, copy, paste. And we end up with x is equal to 3,700 divided by 813. And if I round it, so that's 4.55% of our student would be decreasing. Now, those aren't real numbers. Those are made up numbers. And you saw that in the video. Just trying to give you some real life examples of how that could work. So a decrease of 4.5%, 4.55%. So 37 students is 4.55% change. The bar graph shows the softball players' home run totals. What is the percent of change from 2007 to 2008? So 2007 was 28, 2008 was 20. We're talking home run. So 28 to 20. So this is the 2007 timeline. This is the 2008. So which happened first? Well, 2007 happened first. So just keep that in mind for later work. The change that happened is that there is a decrease of 8 home runs. Which happened first in time? 2007 happened first. So that was the original number that we're looking at when we compare these two seasons. What is the percent that it changed? So we take cross products in solving. When we do that, we've been doing that over and over and over, we get 28x is equal to 800. Divide both sides by 28, copy, paste, copy, paste. And we end up getting that x is equal to, so we have 800 divided by 28 is 28.5% change in home runs, a decrease. So that would be a super big bummer for that player that there's such a big change. What is the percent of change from 2000 to 2006? Okay, so this one happened first in time. So the first thing we have to figure out is the change that happened. So 138, I like to take the bigger number first, right? So then I don't have that negative. Negative just means it's a decrease. But that would be a 20,000 change. So there's our numerator. The change in the population is 20,000. We have to figure out what happened first over time. You should know that 2000 happened first over time. So that would be the 11800 would be the thing that happened first. So taking cross products and solving, then I'm not going to show all my steps on this one because we've been doing cross products for a long time. Let me double check that. And I end up getting 16, and I didn't show all my steps there, 0.95% to the 100th place. You could go to the 10th place. I'm not super picky on the rounding on that. So it's a 17% change that happened in this particular kind of time. It was an increase in population from 2000 to 2006. So an increase of 20,000 ends up being about 17% in this scenario. All right, here we go. Some word problems on percents. You answered 14 out of 15 questions correct on a quiz. What percent did you receive on the quiz? So we take cross products and solve. We get 15x equals 1400. We're trying to find the percent, trying to get it out of 100. We're looking for what grade did you get on the quiz. And you find out that you got 93.3% on the quiz, which would be an A in math class. Or whatever class you're in, really, would be an A. So that's how we calculate a grade. There's faster ways, as I mentioned, but that would be one way. There are 8 previews before a movie, so I'm hearing previews. Not sure what I'm going to do with that yet. 75% of the previews are for comedies. Ooh, okay, so I'm going to change my scenario there. You could set up a T-table like that. I'm going to switch it up a little bit. So 75%, changed my mind, are previews. Oh, I misspoke. 75% are comedies. So of the previews. So that we're just thinking about previews, which probably are annoying to some of you. The comedies, 75% of them are comedies out of the total. So that means if we've watched 100 previews, 75% would fall under the category of a comedy. If we had 8 previews before a movie, that's the total, how many of those would be comedies? So how many comedies would be out of 8? If we have 75 out of 100, this is called make a prediction. So we're using percents to make a prediction. So we're going to cross products and solve. So we get 100x equals 600. We're going to divide both sides by 100. And so we get x equals 6. So 6, we would predict using mathematics that we would end up with 6 comedies out of the 8. If the data we had is that 75 out of 100 is what we have for data, we would predict then that would be 6 out of 8. Doesn't mean it will be perfect, but that's our prediction. Still doing word problems for percent. Fane had 121 hits out of, there's that keyword out of, 365. What percent of the time was a hit? Taking cross products and solving, and I'm going to show it the faster way this time, just as a quick review, even though the learning target is on proportions. And I did this quite a bit in some of the videos, but the division, then we would just divide this out. We wouldn't need this step. So we would have 121 divide by 365, and we get 0.33. I'm going to cut it off right there. And then to get to a percent, we would multiply by 100, which is basically undoing that step right there, which would be 33% of the time that Jane got a hit. So that was that faster way that I introduced to you in that unit instead of setting up that proportion. And maybe for the rest of these, I will continue to do that. I'll do the faster way. So you could still do cross products. You're going to still get 33%, but the faster way, as I just stated, and I did show you that in the unit, is just to divide and then multiply by 100. A quarterback completed 68% of his passes. That means these were completions out of total attempts. Now, not in every game does a quarterback throw 100 times, right? He threw 25 times, actually. Total times that he threw the ball was 25, not 100. How many passes did the quarterback complete? So this one wouldn't be as easy to do that trick. I guess there's ways to do it, but we'll do proportions, cross products. So that would give us, these multiplied out is 100x equals 68 times 25. We're going to divide both sides by 100. And we end up getting that it's 17 times that was completed. So we get 17 completions out of the total of 25. So the last learning target we talked about was simple interest. Okay, so what we call the PERT formula. So P stands for principal, the amount of money you start with. Rate is the percent. It has to be a decimal, and the time is measured in years. So you put $500 into a saving account. There's your P. The account is 3.5% simple interest. There's your rate. We're going to have to convert that. So that's our scenario. That's our setup. First part of the question is asking, what is the money earned after 3 years? So interest, how much do you earn, is equal to how much you start with, called the principal. Now the rate, 3.5%, is really 3.5 hundredths. So if we divide that out, we're just moving it 2 places to the left, so 0.035. We do have to convert to decimal. This has to be decimal form, so 0.035 is the conversion there. Multiply by 3 years. So we get 500 multiplied by 0.035 times 3 years. gives us $52.50. Now, I did have that imaginary placeholder sitting there, but this is a money problem. So that's how much interest you earn in 3 years. That would be like free money. Now, some kids would say, well, that's not very much money, but $500 isn't a ton of money to invest. Okay, so that's how much you get to increase your account. So the balance then would be the 500 you start with. You get that back, right? If it's your bank, if it's your investment, and then you add the 5250, which gives us 552.50 would be what we call your balance after the 3 years. So you get your 500 back plus the interest that you just earned. All right, next question. You put $1,000 in your savings, so that sounds like principal. The account, earns 100 simple interest. There's your I. And you're keeping it in for 4 years, which is your time. So this is going to be a build house, build fence question. Your job is to find the rate. And remember that rates are percents, but go in as decimals. Okay, so, this is a little spicy here. Interest equals principal times rate times time. Coolio. Here we go. So we have $100 that we made. That's the money you earned. See how they say you earned it? That's free money. 1,000 is what you start with. The rate is unknown, and the time is 4 years. Okay. So let's clean this up a little bit. We're looking for the rate, but on that right-hand side, I'm going to combine through multiplication because that's operation. Those 4,000 R, and we're going to isolate for R by division, copy, paste, copy, paste. So our job is to find the rate. So you have 100 divided by 4,000 is 0.025. Now we have to convert that to percent for the rate. So in the formula, that's what we use. We use the decimal form in the formula, but the actual percentage, we're gonna have to convert back. And we do that by multiplying by 100 to get it back, which is the same as moving the decimal 2 places to the right. So that would be a 2.5%, what we call rate. And you maybe have heard that on a commercial before. A lot of times, like auto insurance, things like that, or auto sales, they talk about the rate or the APR, annual percentage rate. All right, here we go. What happens if it's not measured in years? We're going to talk about this example. So you deposit 300 into an account. That's the principal. That's the beginning. Here's our rate. We're going to have to convert that to a decimal. What is the balance? Total money, total, after 9 months. So we're going to have to talk about how to get that out of years. All right, here we go. Interest is equal to 300 times the rate. Now 7% is really 7/100ths, is 0.07, 7/100ths. Divide by 100. Remember, it has to go in as a decimal. And this has to be measured in years. So 9 months is really 9 out of 12 months in a year. So 9/12ths of a year. So you got to put it out of 12 when it's not measured in years. So we're going to just multiply that all out on our calculator. That's going to be so exciting. So 300 times 0.07 times 9/12ths, cool, gives us $15.75. That's the interest that is earned. Okay. The question is asking, what is the balance? What's the balance on the account? So that gives us 300 plus the interest earned is $315.75. So that's how much you would get at the end of the 9 months. Now, 7% is a nice interest rate. So that's growing significantly larger than the last example. All right, so that is our unit on percentages. You know that there's faster ways to solve a percentage. The last unit was all on proportions, but if you had, 3/5 and you needed the percentage, you know that in this unit we talked a faster way to solve is to skip that step, divide it down, and then multiply by 100. And that's just a really fast way to do it in your calculator. So just a quick note on that. If you need any help, reach out. Your test on percents, if you have a calculator to help support you, you should be able to handle it. Please reach out if you need anything. Have a glorious